This lesson is about transformations and congruent figures. So our objective in this lesson, students are going to define congruence and identify the three rigid motions that result in a congruent shape. Okay, so we're going to start by defining this word congruence because we'll be using this term throughout the entire year. Okay, so here is the definition for congruence. Figures, and by figures I mean triangles, circles, any other kind of polygon, any other shape. Figures are congruent, and the symbol for congruence is the equal sign with the tilde on top. Figures are congruent if and only if their corresponding sides and angles are equal in measure from one figure to the other. That's what corresponding means. So basically, that means the figures have the same size and shape. That means they are congruent. Okay, so next we're going to talk about the notation when marking up figures to show that they are congruent. Okay, so for notation, tick marks and arcs are used to denote congruent sides and angles. So I will show you what I mean by that. I'm going to scoot this up a little bit. If I have two triangles that are congruent, I'm going to try my best to draw them the same size and shape. So here's triangle ABC. And then I'm going to draw a second one that is supposed to be the same size and shape, D, E, F. But here's the thing, I don't have to draw them perfect because I'm going to mark up these two figures, and once I mark them up, you will know they are congruent. So here's what I do. For corresponding angles, I'm going to say A corresponds with D, B with E, C with F. If I'm marking up the angles to show that they are congruent, I would put a single arc mark with A and D because they match. I could do 2 at B and E because they match, and you could do 3 at C and F. Here's what this says. That means that the measure of angle A, is equal to the measure of angle D. However, the measure of angle A is not equal to the measure of angle B because they have different tick marks. That's what that means. And we can do the same thing with the sides. I can mark up AB and DE. So they are the same length. I have a single tick mark. I'll use 2 for BC and EF. I'll use 3 for AC and DF. And again, what that means is the length of AB is equal to the length of DE. However, AB is not equal to AC or BC. These are actually, we call these two triangles scalene if I mark them that way. So here are some things we need to know. Let me scoot this up again. If triangle, so for triangle ABC to be congruent to triangle DEF, 6 things have to be true. Okay, the measure of angle A is equal to the measure of angle D. The measure of angle B is equal to the measure of angle E. The measure of angle C is equal to the measure of angle F. It's tedious, but and you know there will be shortcuts later, but this is what you have to understand. All 3 pairs of corresponding angles are equal, and all 3 sides of all 3 corresponding sides are equal in measure. So the length of AB is equal to the length of DE. The length of BC is equal to the length of EF. The length of CA is equal to the length of FD. When you have all 6 things, that's enough to say that triangle ABC is congruent to triangle DEF. Okay, the next thing about congruent figures and labeling them, the order of the letters is important. You have to go in the order of correspondence. It doesn't matter which letter you start with, but when you do the two sides, when you're writing a congruent statement, you have to have correspondence. So let me draw a quadrilateral, and I'm going to label him A, B, C, D. Incidentally, when we are labeling, we go around. We don't go back and forth. Okay, so you have to go around. It doesn't matter which way you go around, but if I said draw and label A, B, C, D, you have to go all around one way or the other. Okay, you can't go back and forth. All right, so that's A, B, C, D, and I'm going to try to draw kind of the same thing, but then I'm going to label it so we know they're congruent. Okay, up here I'm going to label that Z, W. Make sure you're labeling your diagram the same as mine because I'm trying to make a point here. Okay, now I'm going to mark these up and so we can write a congruent statement. Even though they don't look the same size, that's okay. Drawing is not to scale. I'm going to mark them so we can say that they are the same size. Single tick mark at A, single tick mark at Z. 2 at B, not tick mark, arc. 2 arcs at W. 3 at C, 3 at X, and then we try to do 4 at D, 4 at Y. Okay? But I also have to label sides. Single tick mark at AB and ZW. 2 between BC, 2 between WX, 3 between CD, C and D, 3 between X and Y, and then 4. That tells me that all 4 angles in one figure are different measurements. All 4 sides are different measurements. So if I'm going to write a congruent statement, what that means is I want to say A, B, C, D is congruent to something. Okay, I would say A, B, C, D, quadrilateral, you could say quad, is congruent to some other quadrilateral. Okay? You have to have correspondence. You can't go in alphabetical order. You have to look at the diagram. A corresponds with Z. B corresponds with W. C and X. D and Y. So, in this case, it's quadrilateral Z, W, X, Y. Okay? So you've got to have correspondence when you write your congruent statement. Next, we're going to define the term transformation. Okay, a transformation is a change in the location or size of a figure. There are 4 transformations that we will study. 3 of them are what's called rigid motions. Okay, and a rigid motion produces congruent figures. So I'm going to use the symbol for congruence because it's shorter than writing out the word. So a rigid motion produces congruent figures. And we have 3 transformations that are rigid motions. And I think you'll remember these once we go over them. The first one is a translation. The second one is a reflection. And the third is a rotation. So I'm going to briefly define these 3, and then we spend a lesson on each one, looking at each one in more detail. So the first one we're going to look at is called a translation. And a translation moves what we call a pre-image vertically and horizontally. So you're just shifting the image or the pre-image around. You're not turning it or flipping it or anything. So if I drew a pre-image here, and we typically stick with triangles when we do these pictures. A, doesn't have to be triangles, but that's what we do. So this is called a pre-image. So the figure before a transformation is the pre-image. And if I translate it, we use, if I translate it, I just move it. So it's not rotated, it has the same orientation as the beginning. And then my image, we usually label with the prime. So now that triangle is A prime, B prime, C prime. So that's the image. Translations are done with a translation vector. So if I start at A and I draw an arrow to A prime, that's my translation vector. And you would have the same, you would have parallel vectors if I connected B to B prime and C to C prime. And again, we'll get more in detail about that on another day. But that's called a translation vector. A translation vector. And if I wanted to label one of them, it would be A prime with the arrow at the top. So a vector, the symbol looks like a ray. Make sure I see the A prime there. And it is a directed line segment. So once I have this, and it's just a translation, a translation is a rigid motion, and rigid motions preserve distance and angle measure. So I can say that triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, the second rigid motion is called a reflection. And a reflection produces a mirror image. You're flipping the object over a line of reflection. So if I draw a triangle here, and this is DEF, there's my pre-image. And if I have a line of reflection, I'm going to keep it pretty basic here. If I reflect that image over the line of reflection, I'll get a mirror image. And let me see if I can draw this roughly. It looks a little bit bigger, but it's not supposed to be. D prime, E prime, F prime. So you get a mirror image of one to the other. Under a reflection, again, a reflection is a rigid motion. It preserves distance and angle measures. So I could say triangle DEF is congruent to triangle D prime, E prime, F prime. Finally, we have a rotation. So a rotation will turn a pre-image around a point. This one is a little bit trickier to do if I'm drawing it, but let's see what we can do here. If I have X, Y, Z, so this is X, this is Y, this is Z, and let's say I have a rotation point, and I want to rotate about that point. Well, you can connect any pre-image point to the rotation point, and let's say I'm going to rotate it this way. It would be the same distance away from that point, so that would be Z prime, and everything else would spin around that point. So if I tried to eyeball this, and I turn it, let's see, that would go there, that would go here, so Y prime would be up here, X prime would be over here, and that's not a very good drawing of it, but we'll do what we can. Okay. It'll be easier to see when I do some demos on Desmos in class. Okay, X prime, Y prime. So the whole figure rotates. Again, even though my drawing doesn't look like it, angle measure is preserved, distances are preserved because nothing has been stretched or shrunk. So if I just label these things here, they are still congruent. So triangle X, Y, Z is going to be congruent to triangle X prime, Y prime, Z prime. When you use the prime labels, it's a lot easier to write correspondence because it's just X and X prime, Y and Y prime, Z and Z prime. So we're going to look at each rigid motion more closely in future lessons. But the one thing you have to remember is that rigid motions preserve distance and angle measure. You might be asked to spit that back out on a test. I know it's shown up on the Regents exam. It's quite a bit. Rigid motions preserve distance and angle measure. And that means our figures are going to be congruent. So that's a brief introduction to congruence and rigid motions. And again, we're going to look at each transformation in a separate lesson.